everyone, this is Chinnaiah Kalpana here. In this video we are going to solve a differential equation from higher order linear differential equation. So let's get started. Problem: solve d square minus 4 into y equals to e power x plus sin 2x plus cos square x. So firstly let's find order and degree of the given differential equation. Identify the highest derivative. Here d square is the highest derivative, so order will be 2. And the highest power of the highest derivative is a degree. Degree is 1. Or just write the given differential equation as d square y minus 4y equals to e power x plus sin 2x plus cos square x. We know that d is the differential operator, d by dx. Then d square will be d square by dx square. Right? Now we can write d square y as d square y by dx square minus 4y equals to e power x plus sin 2x plus cos square x. Here d square y by dx square is the highest derivative, so order will be 2. And the highest power of the highest derivative is degree 1. Right? Now coming to the problem. Solution. Given differential equation, d square minus 4 into y equals to e power x plus sin 2x plus cos square x, which is in operator form. F of d into y equals to q, where f of d equals to d square minus 4 and q equals to e power x plus sin 2x plus cos square x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function and yp is a particular integral. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by taking RHS to 0, we'll get f of d into y equals to 0, which is the homogeneous equation to the non-homogeneous equation, or homogeneous equation of non-homogeneous equation, we can say. And we'll find yp using 1 by f of d into q. So firstly, let's find yc using the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. The auxiliary equation of homogeneous equation is f of m equals to 0, where f of m equals to, here we are having f of d equals to d square minus 4. So let's replace the differential operator by m. So that we'll get f of m equals to m square minus 4, and the auxiliary equation becomes m square minus 4 equals to 0. We can write this 4 as 2 square. Right? Now this is of a square minus b square form. You know that a square minus b square equals to a plus b into a minus b, right? So we can write the above equation as a plus b, that is for a equals to m and b equals to 2. We can write it as a plus b, m plus 2 into a minus b, m minus 2 equals to 0. Now equate each factor to 0. From m plus 2 equals to 0, we'll get m equals to minus 2. And from m minus 2 equals to 0, we'll get m equals to 2. We got roots m equals to minus 2 and plus 2, which are real and distinct. Therefore, m equals to minus 2 plus 2 are the roots of our auxiliary equation m square minus 4 equals to 0. which are real and distinct. Now we can write complementary function. We know that if two roots are real and distinct, say m1 and m2 are real and distinct, then the complementary function will be one constant into e power one root into x plus the other constant into e power the other root into x, right? Now for m1 minus 2 and for m2 2, we can write the complementary function as yc equals to one constant into e power one root into x plus the other constant into e power the other root into x. Then yc equals to c1 e power minus 2x plus c2 e power 2x. Now we can find particular integral. We can find particular integral using yp equals to 1 by f of d into q. We have f of d, d square minus 4 and q, e power x plus sine 2x plus cos square x, right? Now we need to replace cos square x by some identity, trigonometric identity. We know that cos 2 theta equals to 2 cos square theta minus 1, right? Or you can just write it as 2 cos square theta minus 1 equals to cos 2 theta. Now take this minus 1 to RHS, will get 2 cos square theta equals to 1 plus cos 2 theta. Then cos square theta becomes, take this 2 to RHS, will get 1 by 2 times 1 plus cos 2 theta, right? Now we can replace cos square x by 1 by 2 into 1 plus cos 2x. Since cos square x equals to, just replace theta by x, then we'll get 1 by 2 into 1 plus cos 2x, right? Now this becomes 1 by d square minus 4 into e power x plus sine 2x plus replace cos square x by 1 by 2 into 1 plus cos 2x Now the yp becomes 1 by f of d into e power x plus sine 2x plus 1 by 2 into 1 is 1 by 2 plus cos 2x, right? You can write it as 1 by d square minus 4 into first term e power x plus 1 by d square minus 4 into second term sine 2x plus 1 by d square minus 4 into the constant plus 1 by d square minus 4 into cos 2x. Okay, is equals to 1 by d square minus 4 into e power x plus 1 by d square minus 4 into sine 2x plus, here you are having constant, right? Write this constant as 1 by 2 into 1 by d square minus 4 into, you'll get 1, right? So here what we'll do is, we'll just write this 1 as e power some 0. Also we can write as e power 0 into x, right? If you write e power 0 into x, this of will get the form 1 by f of d into e power ax, right? We'll just write the 1 by f of d into constant as 1 by f of d into e power 0x form, which is in 1 by f of d e power ax form, right, for our convenience. Plus 1 by d square minus 4 into cos 2x. Either you can solve like this or you can find each term separately for your convenience. Okay, if you are good at formula or if you are good at methods, you can just continue like this. or you can find each term separately. Let's name them as yp1, second term as yp2, and third term as yp3, and last term as yp4. See, we already have yp equals to 1 by f of d into e power x plus sin 2x plus 1 by 2 into 1 plus cos 2x, right? From this we got 1 by f of d into e power x plus 1 by f of d into sin 2x plus constant into, in place of 1 we wrote e power 0x, so we'll get 1 by f of d into e power 0x plus 1 by 2 into 1 by f of d into cos 2x. Okay, let's find each term separately for our convenience. Okay, firstly I'm going to find yp1, 1 by f of d into e power x. This is of 1 by f of d into e power ax form for a equals to 1. Okay, we have f of d equals to d square minus 4, right? Now let's see what happens if we replace d by a for a equals to 1. 1 square 1 minus 4, which is equals to minus 3, non-zero. The denominator must be non-zero, right? So let's replace d by 1. Since if we replace d by 1, we get minus 3, which is non-zero. So we'll replace d by 1, or since f of 1 is non-zero, so we can write d, just replace d by 1 is equals to 1 by minus 3 into e power x, which is equals to minus 1 by 3 into e power x, or minus e power x by 3. Or you can write it as minus 1 by 3 into e power x. Therefore, yp1 equals to minus of 1 by 3 into e power x. Now let's find yp2. We have yp2 1 by f of d into sin 2x, right? This is of 1 by f of d into sin ax form. For a equals to 2, we'll find d square. This is given by minus a square. For a equals to 2, we'll get minus 2 square equals to minus 4. Now let's see what happens if we replace d square by minus 4 in the denominator. We should always remember that denominator must be non-zero. If the denominator becomes, the total term becomes 1 by 0 into sin 2x. We know that 1 by 0 is undefined, so total term becomes undefined. Okay, so the denominator must be non-zero. Now let's replace d square by minus 4. We'll get minus 4 minus 4, which is equals to minus 8. Non-zero. The denominator is non-zero by replacing d square by minus 4. So we'll replace d square by minus 4. Then this becomes one by minus 4 into sin 2x, which is equals to 1 by minus 4 is minus 8 into sin 2x, which is equals to minus 1 by 8 into sin 2x. Or you can write it as minus of 1 by 8 into sin 2x. Therefore, yp2 equals to minus of 1 by 8 into sin 2x. Now let's find yp3, that is 1 by 2 into 1 by f of t into e power 0x. We have yp3 equals to 1 by 2 into 1 by f of d into e power 0x. If you consider this, this is of the form 1 by f of d into e power ax. Then for a equals to 0, we'll find f of 0. Since f of d equals to d square minus 4. Find f at 0, which is equals to 0 minus 4 equals to minus 4, non-zero, right? The denominator is non-zero by replacing d by a for a equals to 0. Since f of 0 is non-zero, then this becomes 1 by 2 into 1 by 0 minus 4 into e power 0x, which is equals to 1 by 2 into 1 by minus 4 into e power 0 into x is e power 0, which is equals to 1 by 2 into, you can write 1 by minus 4 as minus 1 by 4 into e power 0 is 1 into 1. Then yp3 becomes 1 into minus 1 is minus 1 by 2 fours are 8, which is minus of 1 by 8 we can see. Therefore, yp3 equals to minus of 1 by 8. Now, we are going to find yp4, 1 by 2 into 1 by f of d into cos 2x. yp4 equals to 1 by 2 into 1 by d square minus 4 into cos 2x, right? So this is of 1 by f of d into cos ax form, right? For a equals to 2, we'll find d square, which is given by minus a square, which is equals to minus, for 2 equals to, for a equals to 2, we'll get minus 2 square equals to minus 4. Now let's see what happens if we replace minus 4 in the denominator. Just take the denominator part under the brackets. We'll get minus 4 equals to minus 8, which is non-zero, right? The denominator becomes non-zero by replacing d square by minus 4. So what we'll do, we'll just replace d square by minus 2 square equals to minus 4. Then this becomes 1 by 2 into 1 by replace d square by minus 4, we'll get minus 4 into cos 2x, which is equals to 1 by 2 into 1 by minus 4 is minus 8 into cos 2x. Now we can write it as 1 by 2 into, we can write 1 by minus 8 as minus 1 by 8 into cos 2x, which is equals to 1 into minus 1 is minus 1 by 2 8s are 16 into cos 2x, or minus of 1 by 16 into cos 2x. So therefore yp4 equals to minus of 1 by 16 into cos 2x. Now we are having the values of yp1, yp2, yp3 and yp4. So let's replace it. Result obtained from yp1 is minus of 1 by 3 into e power x, plus result obtained from yp2 is minus of 1 by 8 into sine 2x, and result obtained from yp3 is minus of 1 by 8, plus result obtained from yp4 is minus of 1 by 16 into cos 2x. Therefore, yp equals to minus of 1 by 3 into e power x, minus of 1 by 8 into sine 2x, minus of 1 by 8, minus of 1 by 16 into cos 2x. Okay, now leave it. If you have any yp of the form some 1 by f of d into constant, we'll try to write in form f of d into some e power 0x. Okay, we'll just write this constant first, and then 1 by f of d. In the place of 1, we'll replace 1 by e power 0x. Okay, this comes in the method 1 by f of d into e power 0x. Okay, it comes under this method. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Right? We have yc c1 e power minus 2x plus c2 e power 2x. And yp is minus of 1 by 3 into e power x minus of 1 by 8 into sine 2x minus of 1 by 8 minus of 1 by 16 into cos 2x. This completes the problem. Now let's see how to find yp directly without taking iterations. Fine. In the first term, the denominator we are having d squared minus 4, right? This is of 1 by f of d into e power ax form. For a equals to 1, if we replace d by 1, we'll get 1 minus 4, which is non-zero. So we can just write directly. Okay? Yes. Here, this is of 1 by f of d into sine ax form. So here we need to try d square equals to minus a square, which is given by minus 2 square minus 4. If we replace d square by minus 4, then the term becomes non-zero. If we replace d square by plus 4, say, if you get plus 4, then this becomes 4 minus 4, which is 0, right? But here we got minus 4, so definitely denominator will be non-zero. So replace d square by minus 4. Minus 4 into sine 2x plus 1 by 2 into, here replace this of 1 by f of d into e power ax form for a equals to 0. If we replace d by 0, 0 square is 0, minus 4 is minus 4, non-zero, so we can write it as, we can just write directly 1 by minus 4 into e power 0x is, we know that e power 0x is e power 0, which is 1, right? So we'll get 1 by minus 4. Now, coming to the last term, 1 by 2 into, and this is of 1 by f of d into cos ax form, right? For a equals to 2, we'll find d square, which is given by minus 2 square equals to minus 4, right? If we replace d square by minus 4, the denominator becomes non-zero. Minus 4 is non-zero since, right? What happens if we get 4? If we get d square equals to 4, then 4 minus 4 will be 0. Then we can't replace d square by minus 4. Then what we'll do? We'll just write 1x and find f dash of d into cos 2x, right? And we'll go for that process. But in this case, if we replace d square by minus 4, the denominator becomes non-zero. So we can write directly 1 by, replace d square by minus 4, we'll get minus 4 into cos 2x. Right? Now, this becomes 1 by, 1 minus 4 is minus 3 into e power x plus 1 by, minus 4 is minus 8 into sine 2x plus 1 into 1 by, 2 into minus 4 is minus 8 plus 1 by 2 into minus 4 into minus 4 is minus 8, right, into cos 2x, which is equals to, we can write 1 by minus 3 as minus 1 by 3 into e power x plus 1 by minus 8 can be written as minus 1 by 8 into sine 2x plus 1 by minus 8 can be written as minus 1 by 8 plus 1 by 2 into minus 8 can be written as 2 8s are 16, right? Minus 16 you'll get into cos 2x, which is equals to, and you can write 1 by minus 16 as minus 1 by 16. Now yp becomes minus of 1 by 3 into e power x plus into minus 1 by 8 into sine 2x plus into minus 1 by 8 plus into minus 1 by 16 into cos 2x. Okay, if you're really good at the methods, then you can go like this, or you can find each term separately using iterations. Just name each term by yp1 or yp2, whatever it is. Okay, and find each term separately and finally replace in yp. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.